All right, so calcium phosphate, symbol and charge. What's the symbol for calcium? Ca. And what's the charge? +2. Phosphate, it ends in 8. So don't go looking for it on the periodic table. You'll never find it. So what is it? You got to look on the chart. PO4 3 minus.
Do you have to know this by heart?
Do you have to know this by heart? You have to know the ones with the little asterisks. That's why I'm making you make flashcards, so that way you're going to get really familiar with those and you'll have them memorized. All right, so how many calciums do I need to balance out my phosphates? Remember my little trick? I put the 3 down there. I put the 2 down there. So I need 3 calciums for every 2 phosphates. And remember, I have to do parentheses around my phosphates. All right, gallium hydroxide, gallium. Symbol and charge. Ga, 3 plus, good. Okay, folks, hydroxides are exception. You're going to look for it because it ends in IDE, and I've taught you that it ends in IDE. I look at the periodic table, but this is our exception, and it's good. It's OH minus. OH minus. All right, so I need 3 hydroxides to balance out my 1 gallium. I want to caution you on this. Do you know how many students just do this? OH3. That is incorrect, because what that's telling you is you have 3 hydrogens, 1 oxygen, and 1 gallium. That's not what you need. You have to put it in parentheses. That means you have 3 OHs, 3 oxygens bonded to a hydrogen. All right, potassium sulfide. Potassium, symbol and charge. It's a symbol for potassium. It's a weird one. Okay, good. And the charge? Here it is over there. Yeah, it is. So it's well, yes, but it has 19 for its atomic number, but it is got 1 valence electron that it wants to give away. So it's just a charge of +1. Everything in that column is a +1. So this is sulfide. So if I no, sulfate is a polyatomic ion. Sulfide means it's not a polyatomic ion. I can just look on the periodic table. So I look up sulfur, and sulfur is right there under oxygen. So it's got 6 valence electrons. It wants to gain 2. So it's a 2 minus. So its formula is just K2S. All right, aluminum sulfite. So notice sulfide, sulfite. Very close, but aluminum, Al3+, sulfite, if it ends in ite or if it ends in 8, I should be looking at that chart. So what is a sulfite? Two minus, good. Okay, so I need 2 aluminums, and I need 3 sulfites. Do you know how many students I say, they go like this, they're like, there's already 3 of them. No, there's not. There's 3 oxygens bonded to 1 sulfur. You need 3 of these, so you have to do that. Remember, sulfite, by definition, is SO3.
Wait, I thought it was a -2 though.
It is, but when I plop 2 aluminums onto there, which are +3, it balances itself out. So remember, we're trying to figure out the ratio, so that way it's charge neutral. And the trick, right? You take the 3 and you put it down here, the 2 down here. Remember our swap and drop helps us with the ratio. If you're mathematically feeling like, I feel like this is familiar, why have I done this math before? It's ratios, but specifically, remember in math, remember this, how do you add 1/2 plus 1/3? You need a common denominator, and how do you figure that out? You just multiply the other one by the other one. Remember that? Like, you multiply this guy by 3 and 3, and you multiply this one by 2 and 2. So then you get 3/6 and 2/6, and then you can add them.
That would be 2/9.
Just 2/3.
5/6, right?
That would be 2/9.
Did I mess up? Oh, I see. That should be a 2. Messed up. Okay. Yeah, because you can't do that. You got to multiply by 1. So do you remember when you're trying to find a common denominator? And the trick, when you were first learning this, maybe your math teacher just was like, well, hey, look at the 2 and just multiply each other by the opposite. That is very similar to the idea of, you know, if aluminum's +3 and sulfite is -2, just switch them. Just, you know, multiply the other by the other, and it'll all work out. All right, let's do the last one, ammonium. Ammonium, that is my one cation I'm asking you to memorize. You're not going to find it on the periodic table. Ammonium is NH4 with a positive charge, and then oxide ends in IDE. So it's oxygen. I want to find oxygen up there. I find it. It's a -2 charge. That means I'm going to need 2 ammoniums to balance out my 1 oxygen, so I'm going to have to use parentheses. So the rule, kind of the general rule is, if it ends in "ide," I look for it on the periodic table. For the name. And welcome to chemistry. Here's the rule, and then now there's exceptions. I swear chemistry is just a bunch of rules with exceptions. So what are the exceptions? All of them end in "ide" on the periodic table, except there are a few polyatomic ions. What are they? What's a polyatomic ion that ends in "ide"? What is it? Hydroxide. Good. Hydroxide. You'll have to remember so you don't lose your mind looking for it on the periodic table. It is OH minus. There's another one on there. Cyanide. Yeah. Cyanide. And that is Cn minus, a carbon and nitrogen overall charge of minus. So you're gonna be like, cyanide, is it cyanine? Is it cyaninium? Where is it? I can't find it, and you're gonna go crazy, and that's because it's a polyatomic ion. Now, what's nice is if it ends in "ate" or "ite," I-T-E, not I-D-E, I-T-E, "ate" or "ite," you're going to find the name on your chart, or better yet, you're going to find the name in your memory. That is why I'm asking you to memorize these polyatomic ions with the little stars. Tomorrow I'm going to give you, we have a little bit more lecture to do, but I'm also going to give you a trick for how to memorize some of these polyatomic ions, because you're like, CO, what? Minus how many? I don't remember. So I will help you with that.